Hi guys, today we are going to discuss about the concurrent engineering topic. Concurrent engineering, commonly known as the simultaneous engineering. It's a method of designing and developing products in which the different stages run simultaneously or work at the same time concurrently rather than sequentially. This is nothing but if you take a car company, lot of parts are there. So they will do the work, that means they will fabricate the product simultaneously. After producing that, they will do the assembly work instead of assembling one by one component. So simultaneously we can able to do the operations. That means no need of the sequential operations. By this process we can able to consume less time, and we can able to generate more revenue or more profit. Concurrent engineering aims at full harmonization between the increase in product quality and the reduction in development time and cost through structuring of product development that involves a large design team conducting simultaneous and interconnected analysis and synthesis actions in relation to all the phases of development. For example, production of engineers need not to wait until the design work is completed. Instead, they can work in parallel, suggesting changes for cost effective and simpler production method and steps for efficient design. A tolerance problem that is caught before any parts are made is much easier and less expensive to fix a problem that is found during the assembly stage. Problems are identified and solved as early as possible in the design process, thereby reducing the cost and time involved in the product development. Essential principles of concurrent engineering. Highlighting the role of production process planning and its influence on the decision of the product design processes. Emphasizing the multidisciplinary dimension of a design team engaged in the product development process. Paying greater attention to the customer demand and satisfaction. Considering the reduction of development times and of time to market as a factor of product success and competitiveness. You can see the cost impact of making a decision with respect to the department. Okay, so you see the graph with respect to the time, the cost of impact of decision. That means each and every stage they have to take the decision at the earliest. The time how much we are consuming, we can able to generate more profit, or we can able to reduce the fabrication cost of your product. Now we are going to discuss about the advantages of concurrent engineering. It will reduces the product design and development time, limits product redesign, thereby allowing products to reach the customer in less time at least cost. Enhances productivity through early discovery of design related problems which can be rectified soon rather than at a large stage in the development process. The reduction in time to market helps companies gain advantage over their competitors. Facilitates a rapid response to the last changing consumer demands. Improves product quality through enhanced design and manufacturing. It facilitates your teamwork. Now we are going to discuss about the limitation of the concurrent engineering. It can be effective if all the design activities are performed in a parallel manner and the decision making among different groups are integrated. That means if a decision taking delay in any process, it will affect the whole performance. The concept requires effective collaboration and communication with the team member. That means we have to avoid the communication gap between the team. If it is raised, the problem will be very difficult to solve, or it will consume more time. Requires an effective computer system for data transfer and organizational integration. That is, we need a high computation power for maintaining the system and for fastening the operations. A minor mistake in any stage can impact all the stages the teams are working with the product. That means if any one department consumes more time, it will affect the whole team. That means whole fabrication process.
Concurrent engineering versus traditional engineering. A comparison of the concurrent engineering model and the traditional model of product realization is shown. As it can be seen, there are huge time savings when concurrent engineering is implemented in the design to manufacturing cycle of the product realization. Also, the concurrent engineering method does not lead into problems of implementing the design in manufacturing, such as costly engineering changes. This will result in reducing the overall product cost. In the traditional model, once the design is made, all of the departments that are involved in the product realization are expected to follow it, although they have very little input in the design of the product. A frequently asked question is, how good the design can be without involvement of domain experts. Very often, the design team in the traditional model do not have the knowledge and the skills to make a product that will be functional, of high quality and manufacturable. After the design team completes its task, the production processes are designed based on the design of the product. Therefore, if the product is poorly designed, the ensuing processes will be poorly designed, too. For example, if the manufacturing department has a part that is difficult to manufacture due to the poor design, considerable time will be expended in order to manufacture the part. To accomplish this, sometimes, the manufacturing department introduces changes to the original design, such as either updating the part tolerances or changing the number of parts in the design. At the same time, the changes in the product design may not be either communicated to others in the product realization process or too late to prevent decisions that are based on the original product design. At any rate, the traditional model is vulnerable to a costly and error-prone product realization. CE design method begins with a cost target for the product. The traditional method has no such benchmark. The CE team compares the derived cost of the product design to the targeted cost. It is obvious that by following the CE model, all the disadvantages of the traditional model can be avoided. The difference in the two approaches will be more evident upon study of the overall production cost in the product's life cycle.